Well, hello, this is our first lesson for Unit 1, and as you can see on the agenda today, we're going to be going over examples of data collection and pie and bar graphs. We're going to be looking at using a spreadsheet, and so I'm going to show you some things about using Google Sheets to create the same kinds of graphs, pie graphs and bar graphs, so you'll learn those both by hand and using technology. And your assignment is going to be doing problem set 1.1. Here's a joke. I like this joke. World's most accurate pie chart. So pie charts and bar graphs are two types of displays that we use for showing categorical univariate data. Now that sounds very fancy, categorical univariate data. So let's talk about what that means. Data just means information. Univariate. Well, uni means one, like a unicycle, for example, has one wheel. So univariate means one variable. So there's one unknown thing that we are looking at or asking about in our data set, and that is going to lead us to be able to make a pie chart and a bar graph if that single variable is what we call a categorical variable. A categorical variable is where you put the elements of your data set, you force people to be in groups, I should say it that way. So if there's some kind of grouping to your data, right? So like the groups over here are pie I have eaten and pie I have not eaten. Those are two groups. So if your data is such that you're putting elements of your data set into groups and you have a single variable, that information, that kind of information, is going to work in a pie chart or in a bar graph. Now, I am emphasizing this because sometimes people will try to make pie charts and bar graphs when they do not have this kind of data. And that might make a thing, like the technology might try to guess what you want, but that doesn't mean it's right. So this is why we take a statistics class, because the world is full of examples of adults who do not understand this. And then you will be reading the newspaper or reading your online news source, or you'll be looking at something that your boss or your or one of your coworkers puts out, and you'll be like, that doesn't make sense. And you'll be the one in the room who knows that. And that's a good thing, honestly. We need more people who understand that in the world. Okay, so here is an example of a question that is going to lead to categorical univariate data. If we were in person right now I would do this as a survey, right? So I'm kind of into NFL football, I gotta say. And so that's what came to mind for me as a categorical question I could ask. So for example, the question might be, which of these statements best describes your opinion relative to the NFL? Now, this is a categorical question because I'm asking you to pick one of these four categories that I'm providing you with. I'm not allowing you to just kind of ramble on in an essay about your feelings about the NFL. That is not something available to you. You are being forced to pick one of these groups, one of these categories. Okay, so the statements are, I'm a huge Chicago Bears fan, or I follow the NFL, but I have some other team that I really like. It's my favorite team. Statement 3 is, I watch football from time to time, but I don't really follow it like close enough to have one particular team. And item 4 is, I do not follow football, nor do I enjoy watching it. Someone turns it on in my house, I'm leaving the room. Not my cup of tea. Okay, so think of which of those four would best describe you. Okay, so why does this lead to categorical univariate data? I actually kind of already blew that I told you. It's because there's four categories, right? Forcing you to pick one of them. And this is the data from the last time I taught this class in person. There were 20 people in the room on that day. And this was the distribution of statements. So 8 people were Bears fans. 1 person said, hey, I got a different team that I like. 10 people said, I watch it now and then. And 1 person's like, I hate it. Okay. So with that data, we can then use that information to make a nice pie chart, a nice bar graph. So if we're making a pie chart by hand, it is a little bit of a pain because you do have to use a circle, and using a circle means you have to use the basis for measuring circles, which is degrees. So how many degrees are in a circle? 360 is the correct answer. Good job. So if I have 360 degrees, I need to figure out proportionally how many degrees of the circle would 8 out of 20 represent. So the way that we do that is to take our 8 and say, okay, I've got 8 out of 20. I need to make that into a percent. So I can divide those two and then multiply by 100, or I could use a proportion since 20 is really nice, right? It's just 5 times as many. So 8 times 5 is 40. So I know this is going to be 40%. Now that thing over here isn't always going to work. It's really just because, right, multiplying by 5 in my head was pretty easy. But you could just, think of it as a division problem, right? So if I do 8 over 20, I'm going to get 0.4 on my calculator, and 0.4 is 4/10, which is 40 hundredths. And percent means per 100. Okay, so though that conversion hopefully is something that you can handle, right? 8 divided by 20 on your calculator, get a decimal, move the decimal point over 2 places to the right, and you've got a percent. So then if we find 40% of 360, that's going to tell us how big our angle needs to be. So on my calculator, I would just do 0.4 times 360, and that gives me 144. So 144 degrees is what that sector of my pie chart, that section, so a sector is like a shape like this, right? Like a chunk of a circle, we call that a sector. So my sector of the circle for Chicago Bears fans is going to be 144. So I'd like to invite you now to pause the video and figure out what the other sectors are going to be. You only have to do 2 actually, because there's 2 sectors that are the same size. So 1 out of 20, find the decimal, find the percent, apply it to 360 degrees, and then 10 out of 20, oh, that one should be kind of easy. 10 out of 20, find the percent, the decimal, find the percent, and then figure out what amount of the circle that is. Okay, pause the video and do it yourself. Okay, so here are the answers that I got. So 1 out of 20 is 5%. So when you do 1 divided by 20 on your calculator, you should get 0.05. Move that decimal point over 2 places, that's 5%. And if I take 0.05 times 360, I get 18 degrees. Okay, and then the other calculation you had to do was for 10 people, so 10 out of 20 is 50%. 50% of 360 is 180. That's going to be half of our circle, okay, exactamundo. All right, now the next bit, sorry, my slide's out of order there for a second, out of order, I was confused. All right, so the next bit is going to involve you taking a circle and then measuring out those angles. So if I go back here, I need an angle that's 144 degrees. So I need to do that on my protractor, right? So like if you don't have a protractor, you can kind of estimate these and like we'll be forgiving of that, right? You need to just kind of get in the ballpark. But if you do have a protractor, that would be awesome. You're going to take your protractor. First, you're going to draw a circle. And you can draw a circle pretty easily because you can just use anything in your vicinity that is shaped like a circle, like the bottom of a glass or something like that. So draw a circle. And then you can, if you have a protractor, you can put your protractor down to measure your angle. And if you don't, use your number sense, right? 144. Let's think about that. 144 was 40% of the circle. 50% of the circle would be half. So it needs to be a little less than half. Okay, I mean, not like a teeny little bit, but you know what I mean? Like 40%, right? 40 out of 100. So kind of use your number sense, use your percentages to help you know how to estimate if you don't have a protractor, okay? Hopefully you can find a protractor. Okay, so on my fancy protractor here, you can see that at the beginning, so to speak. There's a 0 and there's a 180. So I want to be following this scale that starts at 0 and go over to where it says 144. Right, wasn't that the angle? Yes. Okay, so be around like 144. So a few just little notes about protractor use, if you did find one. This bit in the middle has to be lined up with the center of your circle. This line that has the 0 and 180 needs to be lined up with a radius on your circle. So you should draw a segment that goes from the center out to the edge, and then base your measurement off of that. Okay. Okay, I'm not so great at using the technology, but I just paused for a second so I could move the protractor over. Okay, so I have now a line at the last measurement that I just made, and then I would base another measurement off of that line. So the next sector that I drew is maybe this one that's 18 degrees, or representing 5% of the circle, and then I would move the protractor again to measure another one like that. For example, here I am measuring that last segment that would, or sector that would also be 18 degrees. Okay, so if I were actually drawing this with a pencil, I wouldn't have these lines like stick out past the edge of the circle. But again, not the best with the technology. You will see as the year goes on, I'm not the best with the technology. But I definitely have now chopped up my circle into the 4 pieces that I need. This part was the part that represented people who were fans of the Bears. Whereas this big section were the people who were like casual fans from time to time. And then there were people who liked another team, and there were people who don't like it. So you could have some labels like this. And another thing that you often will see in pie charts that I would encourage you to do is to include the percentages. So a mistake people sometimes make is because after they draw the pie chart, they're super focused on the degrees that they used. Sometimes people will accidentally label these with degrees, but that's not really what makes sense to readers, right? We don't usually talk about the degrees. We talk about the percentages. So this was 50%. These were each 5%. And this first one was the 40%. So some labels like that would be ideal. Not having these lines stick out would also be ideal. My being better at technology would be a good, would be ideal. So the other thing that you can make is a bar graph. And a bar graph, I asked you here to make a bar graph based on relative frequencies. This is the fancy name given to base things off of percentages. Okay, so relative frequency means percent. So I'd like you to take a minute here. You can see I already have the labels at the bottom. I know I need labels because this is categorical data, so I need the categories. So at the bottom, I have like the Bears, like another team, casual viewer, don't like the NFL. And then on the left-hand edge, you do need to label as percentages. And so you might, for example, choose to label up to 100% and then subdivide by fourths. So then each of these tick marks is 25%. I might choose to subdivide differently. I might, maybe since 2 of these percentages are kind of small, maybe it would be better if I just went by 5s. Let's see how that would look. So if I just went like 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Maybe I could go just up to 60%. And then make sure that I'm labeling, because especially since I'm not going up to 100%, it might be a little deceptive, right? People might think that this bar that's going to be 50% is the whole shebang. Maybe do something like that. I kind of would like it better if it went up to 100% because I feel like that's more descriptive. But as long as you have labels, right, and you're not lying, right? Don't lie with your data. But as long as you have labels, then I think we're in good shape. Okay, so I'm going to ask that you pause and try to make a bar graph that matches the data that we have. All right, so your bar graph should be something like this. Mine isn't super fancy nor accurate. Again, if I were doing this on paper, I'd be using like a ruler and making sure I have like a little bit more precision, but this is the gist, okay? So something that you might notice is that in a bar graph, there can be spaces between the bars, but there also might not be. It depends kind of on the aesthetic of the bar graph. And you could make this going sideways. So you could have the labels on the left and the numerical scale across the bottom. And that's a variation you sometimes will see. So how do you do this with technology? Because, I mean, chances are, you guys, you know, when you have the big fancy corporate job, you're not drawing that and going into your presentation. Okay, so you might wonder, why on earth are you teaching me this? The reason I'm teaching you this by hand, and in particular the pie chart by hand, is because I need you to understand what the computer is doing behind the scenes, right? What is the computer doing in its wee brain processor, whatever. So of course, you're going to be using technology in a workplace environment, in a school environment, to make a graph for your science lab. I understand that. But we want to make sure that you're doing the right thing. So there is a practice file with a link on Schoology for you to make your own, you know, to have your own copy of what I'm about to show you. But I'm just going to show it to you for now and talk about the common mistake that I see students make. All right, so a lot of the time in my decade of teaching stats, I will have students work on a project and they have something kind of beautiful looking artistically, but mathematically horrible looking. They have data over here, like you see in this left-hand column. Oops. Over here, you see data in this left-hand column, right? And so what this would represent in my thinking about it are like the survey we just did, right? So the first person said category 1, they're a Bears fan. The second person, oops, I undid that. Hold on. Okay, so the first person, you know, said they're a Bears fan. The next person said, I watch casually, right? So these numerical codes pertain to the choices that were given in the data set in the survey. And these are folks' answers. Then what sometimes happens is that people will highlight all of this, you know, all the way down the column, and then have the, you know, have the spreadsheet make a graph for them. And it looks like this thing that I have here, this crap. This is not right, okay? Because think of what you are doing. How many categories did we have? 4. 4 is how many categories we had. So we should see 4 sectors at most, possibly less. Maybe there's 0 people who answer a particular thing. And then you'd have fewer than 4 sectors. But you certainly cannot have more than 4 sectors if you only had 4 categories. Okay? So I really want to drive that point home with you because I am sick of seeing graphs like that, honestly. Okay? So what you actually do is you add up the totals, right? That's what we had to do in order to get that other data as well. So a spreadsheet works, it's like a computer, like a calculator, a 2-dimensional calculator. You can see that I preset a little table up here. This is just me writing, doing a little outlining just to make it like stand out. And if you start writing the word count, a bunch of options come up for you. Okay, now if that doesn't happen, just like that, what you forgot is the equal sign. Okay, so anytime you're trying to tell the program, tell the spreadsheet, I am doing mathematical stuff, you need to have an equal sign first. Okay, so equals, start writing the word count, and there's this thing called COUNTIF. That's the command I want you to learn today. You can see up here in the equation bar, it's right there as well. And then I'm going to highlight my data. Okay, so my data goes down to here. You can see that it fills in from cell A2 to cell A51. It has a colon in between. So if highlighting is difficult for you, you don't like the mouse on your computer or whatever, you can just type A2 colon A51. Then you type a comma, a 1, and close parentheses and hit enter. Okay, so what that does is it counted how many 1s are in my data set. Now, could I do that by hand? Of course, but usually data that we are using is on a large data set, and we do not want to have to count it by hand, right? That is sort of the whole point of having technology, is you don't have to do things by hand yourself. Okay, so for the next thing, I'm going to do the same exact syntax, count if, the range of data, a comma. This time I'm going to write a 2. And then I'm going to do this for 3 and 4. Okay, these are the totals that I get. Now I could highlight just this table. I am not going to highlight the original data. When I highlight the original data, the computer does not know what I mean for it to do. Okay, what I really want it to graph are my totals here. Okay, so once I have my total chart, then I want to go into Insert, Chart, and ta-da! Now that is a lovely graph. That's beautiful. It is not identical to the one we did by hand because this is different data, but it is of the same type as what we did. And notice over here on the right, the Sheets program gives you the option of also putting this in what they call a column chart, a bar graph that goes in either direction, right? So this is how I know that I'm firmly in the world of categorical data, right? It's giving me the categorical graph options. In your notes, I would like you to write down enough that you have the steps of what to do on Google Sheets to be able to make a pie chart or a bar graph on Google Sheets. That is an important thing for you to know how to do. So write down enough that you can do that yourself. And I would encourage you to go on Schoology, open that file that I just was playing around with, and make sure that you can do those same steps yourself. And if you can't, be sure to talk to your teacher. All right, your next assignment, your problem set, is problem set 1.1. I recommend that you have some sort of organizational system for your work for this class. You know, keep it in a binder or something, because there isn't a textbook. So your papers that you generate in your computer files, that's it. So make sure that you have some system from the beginning that is going to help you stay organized and be successful. When we get to the end of this unit, you will want to be able to look back and study, and that is going to be really difficult if your stuff is scattered all over the place. So come up with a system and stick with it, and good luck on the problem set.